I'm doing most of the work. You'll probably just be sitting there watching and taking notes here. On the first handout I gave you for the review, I said you're responsible for all those functions. I listed them for you. The graph, the sketch, the logarithmic, exponential, all piecewise. So I'm gonna start out with a piecewise defined function. I think the exam opens up with a piecewise function. So I think it's wise on that handout where it says to sketch. We'll try a piecewise function. I chose this one. See what it looks like. It's been quite some time since we've seen a piecewise function. So guys, this one is given as three pieces, and they look like. Mr. Parker sure get all this recorded for us. And I think that will be a big help for Monday. You guys just came in. Something just came in. You need a handout here. I created something else.
Oh, thank you.
We'll go through. Okay, guys, on the piecewise function, I hope you can see it over here on the side. Let me know. Piece by piece. Is this the one? Remind me. It's been many weeks ago. Is this the one where we actually created maybe a little table on the side for each one, just to get a start? Can we do something like this maybe?
Yeah.
Just to get a start. Each one. I think would be wise. Guys, if I go back to the first piece, I think I actually did these in different colors last time we saw these. Let me keep the first piece in black. X is less than or equal to 0. I'm going to start with 0 since they gave a 0 to me. And also I'm allowed to try anything less than 0. So I'm going to try -2. And that would be up to you. The next one, I'm going to graph this one in green. My table there for 9 subtract x squared. Here's my so-called domains. I'm going to use 0. Try something in between. Then we'll jump down to 3. So from 0 to 3, some numbers there I'll test here. The last one, we're in blue. X is greater than 3. I will start with 3 since they gave 3 to me. Something greater than 3, maybe a 4. And we'll see if that might be enough. See what the sketch may look like. And
So
I've got,
should we use 2 points or 3 points?
it's up to you. Entirely up to you. Now when I put all this together, I've got a few questions about the graph itself. It looks like this. Guys, that first piece, I'm careful here. I think most students by now would recognize, Professor, this is going to be a piece of a straight line. The second one in the green, when I finally get to it, that's going to be a piece of a parabola. Sure, recognize that already. The last one, another piece of a straight line. Guys, if I go back to the first one, I'm using 0 here on my table. It looks like I can use 0. It looks like it's equal to here. If I take it back and replace it in my piece there, -0, of course, gives me a 0. If I put a -2 in here, negative and -2 turns that into a +2. And that might be enough for me to get a start on what does this look like. So this is 0. We'll put -1, -2. Let's go up 2 to get ready for it. So if I plot these guys, it's 0, 0, and can be included. And it looks like also -2 up to is here, can be included in this case. You guys agree with that?
Mm-hmm.
Now connect those two. I have a piece of a straight line. And it looks like this. And like I said, I think the final exam on Monday opens up with one of these. Now the next one, I'll do that in green. Looks like When I do it, 0 cannot be included, but I'm going to use my table here. 0 taken back into my second piece, 9 subtract x squared, it's going to give me a 9. Take 1 back, you're going to end up with an 8, substituting 3 back there, it's going to give me a 0. And this should be a piece of a parabola. Okay guys, 0 up 9, say it's up here, should be open based on what I see. And I got out 1 up 8. And also use 3. So out 1 up 8, guys, we'll just do it right quickly. We'll say H right here. And somewhere in there. And then 3, 0, looks like it may be there. Now, if I do the shape here, it should be a what? A parabola opening down? Based on what you see here, would that be a parabola opening down when I do it? And so is this the piece that we're looking at there? I make it curve like that. So far so good? Make sense? The third piece in blue, I'm using the numbers 3 and 4. X is greater than 3, so I'll take 3 back to my third piece. 3 subtract 3 gives me a 0, no problem there. Put a 4 in, 4 subtract 3 gives me a 1. If I plot those, 3, 0. It looks like 3, 0 was given to me earlier, and I included it. And since it's already been darkened in, I cannot reopen it. Let me do this. So that blue is going to be here. 3, 0, still darkened in. And then out 4, up 1. Somewhere in here. And then when I connect, it should be a piece of a straight line if we have no mistake here. It looks something like that. Take a close look. How's it look? Just plotting points. Looks pretty good. Okay. Domain on the graph itself, that's for the domain after you finish up, which more than likely I will. Guys, can anyone look at this and tell me what the domain is?
Wait, I have a question.
Yeah, go ahead.
How is 4 filled?
4 was filled, any point after this is filled.
Oh, got
This
it.
is an initial point that they give you.
Okay.
Just the initial point that you see actually given to you. You gotta be careful whether it's gonna be open or closed. Good question though. Guys, domain from left to right. In fact, you might be able to tell what right the domain is by looking at these. What do you think? Is it all real numbers? From left to right?
Yeah.
But if that's true, then my domain will be all real numbers. I'll represent it like this. And range the up and down.
0 to 9.
Okay, looks like 0, bracket 0. And does it go through infinity?
Oh.
Yeah.
Yeah, because I was worried about this right here. But does this right here finally pick up? Let's just want to pick up that point that was open back over here. So we got the domain and the range out of the way. Let's see what else I asked about this. Anything. Yeah, right below it. It says use the function and answer these questions. Or use the piecewise function, yes. Find f of, and it looks like I have to start out with f of -4. Now, can someone tell me how on earth are you going to look at this? And find f of a -4. Are you going to replace x by -4 in each of the 3 pieces?
No, you go to
No.
the first one.
Yeah, you go to the one where it fits, and -4, like Aiden said, -4 is less than or equal to 0. Go to the first piece, which is negative a -4, and therefore the answer is 4. The next one I chose to look at, number 2, was f of radical 2. And you know radical 2 is 1 point something. Does that fall in piece number 2? Does it fall right here? Between 0 and 3. So it's 9 subtract in piece 2, square root 2 squared. If I do the math there, I think it's a 7. Next one, number 3, f at pi. roughly 3.14 guys, that's greater than 3, fits here in the third piece, go to the third piece, and I'll accept the answer just like this from the third piece. Now the last one, a student was asking me, Professor, are you going to, since this is the final, it covers everything, are you going to have problems that may relate to many topics together? Like this one says f of sine of 5 pi over 3.
Just half.
Okay, now what are you gonna do here? All of a sudden I put a trig function into a piecewise.
You find that and you plug it in.
Okay, where are you gonna find what?
5 pi over
You're
3.
gonna first have to come up with this.
Right.
So it's f of, and guys, sine of 5 pi over 3, help me out. Does anyone know first where is 5 pi over 3 located?
Quadrant 4.
Quadrant 4, so sine down in quadrant 4 is negative. So I know that much. The value itself, does anyone think they realize what the value was at 5 pi over 3 in quadrant 4? Sarah?
It's 1/2.
Is it 1/2?
Yeah.
Sine of a 60-degree angle is
Okay,
1/2.
sine of 60 should be the same as cosine 30, should be radical
Oh
3.
wait, it's radical 3 over
Over
2.
two.
Yeah.
And therefore, since I now know that, it fits this piece here. Okay, x is less than or equal to 0, and the x she gave me, negative radical 3 over 2 is less than or equal to 0. So that tells me go to piece number 1, and piece number 1 says the answer should be negative of that she gave me. And therefore, that calculation just merely turns into, in this case, this. For your final answer. Okay, now you can open up the test on Monday. I could have something with a logarithm in it, f of log something, where you have to relate and connect. But I did want to bring this one to you guys to show you this right here. This is nice. See a little connection there. Okay, part 1 is done. I don't think we have any mistakes. Looks pretty good. Okay, now part 2. Down in part 2 there. Part 2. Part 2 says now please use transformations and sketch this graph. A lot of sketching here. G of x is equal to the negative side log base 2 x plus 1 plus 3. And they have some questions about that. Guys, I don't know how many colors I have here, but we're going to go through transformations. Let me start out with this. Try green here. This says there's going to be a reflection through which axis?
That's
X. And if I get to x plus 1, someone help me recall. X plus 1 a reflection, or is it a reflection, or what's going on there?
Horizontal shift to the left.
Horizontal shift to the left 1. To the left. Finally, when I reach plus 3, that would be a vertical shift up 3. And then of course got the parent graph also. So let's see what this looks like and a few questions after I get it done. Guys, a basic log graph. A parent graph. Does anyone remember anything about a log graph?
The y-axis is an asymptote.
The y-axis is going to be an asymptote.
it's a 1.
What's it one?
The arrow going up.
The
Well,
x-intercept.
the x-intercept.
X-intercept.
Is 1. And then I'm hearing also, Professor, it should look something like this. And we'll call this y is equal to log. I think I had a base 2 here, I did. X. There's the parent graph. Now let's start the transformations. The green one says reflect that through the x-axis. Guys, see if I'm correct here when I do this. And that's representing y is equal to a negative sign out front, log base 2x. After that, the red says now horizontally shift this to the left. Now I gotta be careful when I start shifting to the left, what must I be careful about?
Asymptote.
The asymptote. Oh wow, nice. Let's shift that asymptote to the left. 1 is now at -1. That's my y-axis. Shift it over. Another nice point is this point here at 1 should be also shifted to the left. It's going to take it to what, 0? Now, am I now looking at a graph that might look something like this? We label this as representing y is equal to a negative sign out front, log base 2x plus 1. Nice little review tonight. And finally, vertically shift up 3. So I know what that means. We'll go up to 3. Guys, on that last graph, for sure, it looks like I'm gonna have a point here at 3. I think you guys would agree with that. Now, what do I usually ask you to do, though?
X-intercept.
Yeah, the x-intercept, y-intercept, looks like we had the y-intercept. So let's try to find the x-intercept. And to find the x-intercept, replace by 0, the function. And you have this, so be careful with this, you gotta solve that. I'm gonna move the 3 over first. Make it look like this. Now, multiply both sides by a negative sign, clean this up a little further. And we'll write that as that. Now, who recalls at this point, what should I do?
3 squared.
I knew you were gonna say that backwards. Be careful.
2
2 cubed. So this means 2 cubed is equal to x plus 1. Guys, this is 8 equals x plus 1. X is going to be equal to 7. And I'll write like this just so you can see it. There's my x-intercept. Now that means if I go back, the x-intercept is out here at 7. The y-intercept we think is 3, but we'll find it just to make sure. And how does one find the y-intercept always? Exactly, go up and replace or find g at 0 in this case, replace x by 0. And we will have this. And guys, looks like it's going to be negative out here. Now this gives me log of 1. What is log base 2 of 1? What's log of 1? Base 2?
0.
0. 2 raised to 0 is 1. Plus 3. And yes, that just confirms what we thought. 0 dropped out. You end up with a y-intercept at 3, which we thought you should. Now that should be enough, I think, to say, wait now, does the graph look something like this? And it comes down, picks up that x-intercept, crosses over. Does not do something crazy like that, but crosses over. It's underneath there. Guys, this part right here is underneath. And there's your final graph, the black is. Now, let me see if on the handout did I have some questions about this. I did. I asked for the domain, the range, and a few more things here. Okay, domain. I think, guys, help me out. What would the domain, the black graph be from left to right?
-1 to infinity.
Absolutely. Range on that final graph.
Negative infinity, positive.
It is. Okay, I gotta keep mind again, this thing brought this below the x-axis out here. Then I think I threw in, let's see, x-intercept, y-intercept, I think we've already found those. Asymptote, no problem. The asymptote is located at x is equal to -1. Bring back fond memories? I'm doing logs. So I've got a piecewise function. I've got a log function. I've got something else here also to make a sketch of here shortly. Yes, sir?
Could you explain that first part of finding the x-intercept?
To find the x-intercept, you set the function itself equal to 0. Are you talking about right here?
Yeah.
Yeah, then I solved it. I moved the 3 over, I solved an equation. And then here, right here, Aiden helped me out here. That was the tough part, you had to translate that, what it means. It means 2 cubed is equal to x plus 1.
Oh, okay.
Then you find that
Yeah, right.
for the x-intercept.
Yeah.
Okay?
Yeah, thank you.
Now, the next one. I will ask the class when I jot down what I wrote in for the example. I debated about which one to do here. This is part 3. And this one is to sketch a rational function. Looks like this. And it's, I will get out of your way here so you see it. Now guys, you see a rational function on the exam Monday, what are you gonna do first? A ratio, a fraction of 2 functions. What are you gonna do?
Domain.
Well, I am, but something else that I think is calling for it to be done here, even before I jump into the details. What is it? Well, something else.
Factor.
I better factor. And I hope these factors, I will factor, 2x, x, oh boy, what, -1 here, maybe +4 here, let me check my math here.
You got it.
And the last one, or the denominator, should factor,
Plus or minus
is it x plus 2, x minus 1?
one. Or plus two.
What's that?
No, you got it.
Maybe don't scare me. Is that true now?
Okay.
Now, first, this may happen on Monday, but it's not happening here. Did anything cancel out? Or would anything cancel out in the blue? No, therefore there is no hole in the graph.
Shouldn't that be?
Yours on Monday could, something could cancel out. Okay? Are we okay, guys?
Shouldn't it be x minus 2 and then x plus 1?
Where's that?
The factor?
I hope I'll plot this out for me. Is this, will this give you x squared plus x minus 2?
Yeah, because you need positive x's in the middle.
Yeah.
Sorry.
Yeah, maybe I should have brought it, some factoring skills. Go from class. No, that factoring, one of my colleagues said that's what's wrong with his math 7 class, they couldn't factor. Yeah,
So what if, two of them were like canceling each other out, that means?
there's gonna be a hole in the graph.
So for what exact, for the x-plane?
Yeah, okay, hang on, it's not happening here, it could happen on yours though.
Yeah, for example.
Let's say, the x plus 4 canceled out, there's another x plus 4 down
Yeah.
here, they cancel. And you take that to the side, solve it,
Oh,
and that's gonna tell you where that hole's gonna be located. The x is -4. Does anyone recall, how would you find the y coordinate? Or the point at which a hole shows up? I got the x coordinate. What would you have to do to find the y coordinate?
Oh, you set it to your horizontal asymptote?
No, something else. You're talking about crossover.
Oh,
Swap x and y, right?
Yeah, you're going to go back to this, whatever it simplifies into after that cancels out. You go back to it and plug in. The x was a -4. And then you'll get this right here.
so it's not like an asymptote, it's just.
No. Okay?
And then you basically solve that part on the left, and then whatever you get, you put in x
Replace
instead
x
of the
by
y.
negative. Replace x by -4 and you'll get the y.
Oh, replace x by negative.
Yeah.
Oh, I
I
thought
said
you,
the x
I thought you said
-4.
replace y by.
No, you want to find the y. And then that's going to act as your hole on the graph. Didn't happen here, but I think if you look back through your notes or a quiz or something, it may have happened on something we did in class. Guys, nothing's happening here, but I think now, let's see if I can jump in and start answering some questions here. I have, I think, on the handout here, sort of what it may look like Monday. Domain. Guys, the domain in this case is x cannot be -2 of the 1. If I see that much, I'm happy. Number 2. Someone close that door for me. too happy out there. Way too happy. Range. Now the range, I may have to wait till I sketch it. Okay, then look at the sketch and try to get the range. Now, some students may look at those and say, no, Professor, I think I can sort of figure out the range now. But we'll sketch it first. Let's see if there's anything else I can do. Oh, vertical asymptote, oblique asymptote. We're into the details here now. So guys, let's do this. Horizontal asymptote. If there is one, we gotta name it. What's a quick way to name it if it exists?
So the denominator 0.
It's 2.
That's the vertical.
It's 2.
Yeah, why is it 2?
The leading coefficient.
You lucked out. The leading coefficient, the degree is the same. Always, if that happens, and you're hoping that happens on Monday, the horizontal asymptote is merely the ratio of those coefficients. 2 over 1, so we'll write y here. 2 over 1, so it's 2, so my horizontal asymptote is located at 2. Now, before I go further, David, I bet you're going to ask, why if they're not the same? Well, if they're not the same, you're showing one the same here, Professor. Suppose I open my test on Monday, and I see a 3 here, and maybe a 2 here. They don't match up.
Cross multiply.
No, see, you forgot.
Wait.
And you're trying to find an asymptote, and it's not horizontal. It's horizontal only if they match up, the degrees match up.
You do the division thing?
Yeah, you gotta do the long division and come up with an oblique. So watch that, you better write yourself a note, just in case you have an oblique. I have a horizontal on my example here, yes.
So it, just to clarify, if exponents are different, you will not have
A horizontal.
a horizontal, you will only have an oblique.
Okay, and we're gonna have an oblique for us in math 2, especially if this one on top is one larger than the one on the bottom. Maybe a 3 here and a 2 here.
So if it's larger as a oblique asymptote?
Yeah, it's oblique if it's larger by 1. So like a 3 on top and a 2 on bottom. Then you gotta use that, like you said, the long division we talked about in class, and come up with an oblique asymptote. And we did an oblique in class, didn't we? Well, of course we did. This one has horizontal though. Next question would be, is there a crossover point? Oh, this is going to be fun. Is there one of these? Who recalls how to find, does my graph eventually cross over the horizontal asymptote? Does anyone remember what we had to do?
You said,
Sarah?
You have to set the function equal to the horizontal.
Yeah, you take the horizontal asymptote, the 2, and set it equal to the function, and I'm gonna use the original function given, and see if they have something in common. Can you solve it? Yeah, it's gonna look like this. Quick little cross multiplication is gonna give you 2x squared plus 2x, subtract 4, and of course 2x squared plus 7x, subtract 4. I just did a quick cross multiplication with the understanding that's like 2 over 1. And we'll try to solve it. I hope I don't have a mistake up here. If I try to solve this one, guys, the 2x squared drop out. Thank goodness. If I move things around, looks like maybe I'm going to end up with, help me out, 0 is equal to 5x. And therefore, x is going to be equal to 0. So I do have a crossover point. So x is 0, and if I have a crossover point, I know what y is. Y is 2. That's my horizontal asymptote. So there's my crossover point. Now, can you tell me before I go further? Something strange has happened on this one. 0, 2 is also what besides a crossover point? Yeah, that's the y-intercept. So 0, 2 is going to act as a y-intercept when I start sketching, and also it's going to be a crossover point. We'll see when we get the sketch started.
Professor, how should I 0?
Right here, move the 4 over here, add 4,
Okay.
and they cancel out.
But what about the 2x?
Right here.
Or
I move about 2x over here, I subtract 2x, I got 7x, subtract 2x, got 5x.
Okay.
Don't you scare me this week.
Sorry, we forgot how to do math.
Well, we forgot how to factor, we forgot how to take 7x and subtract 2x or whatever x,
See you in winter.
you will see.
Yeah.
Yes, go ahead.
Well, what do you do exactly to find that crossover point?
Yeah, the crossover point will be, you set the, whatever this comes out to be, that's your horizontal asymptote, you set equal to the function. And see if they have anything in common. So the horizontal is set equal to the function. And see if it works out. Okay. Number 4. Now I'm gonna pick up vertical asymptotes, and Aiden, I heard you tell me how to find those. This is where you set the denominator equal to 0.
Yeah.
So you say this equal to 0, end up with these vertical asymptotes. X is equal to a -2 and a +1. If we have no mistake, and I don't think we have a mistake. Okay, guys, let's see what else, and we'll get the sketch done here. Vertical, oblique, there is no oblique on this one. Horizontal, we got it. Crossover, yes, we got it. No hole on this. X-intercept, Y-intercept, I don't have those yet. Pick those up now. Let's pick up the X-intercept first. Guys, to find the X-intercept, I'm gonna set my function equal to 0, like this. And this. This should be a big help to you guys when you start redoing yourself. Like that, do a quick cross multiplication, it merely comes down to this. And I'm hoping that quadratic will factor 2x, x, step back, I think it's what, +4 -1, I better watch my factor myself. Okay, looks good. Solve this, guys, we have 1/2, and here a -4. Let me list those like this, 1/2, 0, -4, 0.
So you only set the top equal to 2?
And that's the fastest way to do it. That's exactly right. Find the y-intercept. That's merely you go back and replace x by 0, in other words, r at 0. And you usually do that without much thought here. Guys, if I replace these x's by 0, I'm going to end up with -4 for a -2, which is 2, and I'm going to write like this. That's my y-intercept, and our guess here was, in this case, it is the same as a crossover point. Sometimes that can happen. We're ready for the sketch now. And a few questions. Yes, sir?
How did you get to 0 is equal to 2x plus 7 minus 4?
That's why you find an x-intercept. You set the function equal to 0.
No, I mean like the second step. Like,
Oh,
how
like
did you
this.
get rid of the denominator?
Just quick cross multiplication. Multiply in that direction, multiply in that direction if you want to do it quickly.
But isn't that like the same as multiplying by, X
Same as
squared
multiplying by
plus-
x squared plus x minus 2, both sides.
are you allowed to multiply by x?
You're allowed to multiply by x squared plus x minus 2, because when you multiply it by 0, that's where the 0 comes in. 0 times anything is 0, so you get this.
Oh, I thought.
Now though, Aiden told me this. He says, not the x-intercept, he was talking about something else. Okay, I see. You see that cross multiplication?
Yeah.
Yeah, that's just really solving an equation. Now, I think I have everything. Now, I don't know what the graph looks like myself, so you guys are going to help me out. It's going to be a strange looking graph. And they've got a few questions about it. Sarah, is this helping out so far?
Yeah,
You appreciate this?
yes.
Thank you. Now, let's start putting things together. Guys, by the way, that range is still missing. I don't care what you place on here first, it's up to you. If you will go to that horizontal asymptote and go up to 2 and say, Professor, I want to go ahead and do that. Go for it. Be patient with that. And the horizontal asymptote here. This one looks like this. horizontal asymptote. Crossover point, we'll get to that here shortly. It's actually supposed to be 0, 2. Guys, if you want to plot that down, 0 up 2 is right here. Which also is a y-intercept. So that got it out of the way. X-intercept, I'm just going to pick that up. -4 is out here. I'll mark it here. So we got the x-intercept, y-intercept, we got the horizontal asymptote, we got the crossover point, doing pretty well here. I think is that it, where's the vertical? -2, okay, got one here. And also at 1. So we do this to show vertical. And here. Okay. Looks like that. Now, we got a graph. Let's step back and look at it, guys, make sure everything's on there. X-intercept, y-intercept, crossover point, horizontal, vertical. I think everything's there.
What's the 1/2?
Oh, and the x-intercept, I didn't put them, where am I? Oh, 1/2? Oh boy, I almost left it out here. 1/2 0 is right in here. For an x-intercept. -4 marked already. Now, do I have everything now? At least on there? Now, how many pieces will this graph have? 3 pieces. Something to the left of this vertical asymptote. Here's this one. There's something going on over here. There's something going on in between, and there's something going on to the right. Let's start on the left. I have to follow those asymptotes, the red and the black, and pick up that x-intercept. What might that shape look like? Yes?
I had a question.
Go ahead.
What's the difference between the oblique and the horizontal?
I will show you.
Okay.
You got horizontal here. Guys, will this now maybe look something like this? Gotta come down, pick up that x-intercept and sort of follow those asymptotes. Is that possible? That's that one piece done. In between, a little tricky, you're in between those two vertical asymptotes. Looks like to pick up the y-intercept, x-intercept, a little strange, but might it look something like that. In between. Out to the right, I have nothing to work with. I can plot a point. But what? Someone tell me, Samantha, where must the last piece be located?
Top right.
It's gotta be, the top right up here. And follow those asymptotes. And there's the graph. Done. Or you can plot points to see what it is. Now, I'll get your question about the oblique. This one is done now. And guys, on the handout there, since I created this handout, I think it's a beautiful handout. Let's see if I got everything done here. I do. Now, can anyone tell me what type of a question could I ask you after you do all the graphing, David? I usually have maybe a question or two about this. In fact, the range, we don't have the range yet. David, could you help me out with the up and down now since I have the graph itself? How would you describe the range?
All real numbers.
You guys agree? Is it all real numbers? The way the graph looks? So he says, Professor, based on the graph, it's this. Do we agree? With the range, the up and down. Now, who has, or can recall, something else I may ask you, since I have the graph, that's critical for calculus.
The limits.
And the limit. Like we asked for a limit as x is approaching, and guys, I'm gonna try one of these vertical asymptotes. Let's approach -2. Let's approach -2 from the right
Negative infinity?
of this function. So you're approaching -2, but you're staying on the right-hand side of -2. Guys, here's -2, staying on the right, over here on this right-hand side. What's my graph doing on the right? Close to -2. Is it up here approaching infinity? How's infinity? Is there anything else that I could ask? Since you have the graph, Marco, you remember?
Well, we still have to write the domain,
I think we got the domain out of the way.
or we're not writing
If I ask. If you just put x cannot be -2 or 1, I'm good. Okay,
Maybe if there's like a crossover point with the horizontal asymptote, or no?
well, the crossover point here is strange, it came out to be the same as the y-intercept.
Oh, yeah.
I think, guys, didn't it? Isn't this a crossover point here? And it came out to be just in this particular problem, the same as, usually it's not, the same as the y-intercept. Is that pretty good? Now, before I do it, before I leave it, your concern was if, and Nathan, you were asking, if this had been a 3, the degree is 3, and this one remains a 2. In other words, the one on top is exactly 1 larger, then you have an oblique, which means you have problems. You have issues on this one. What would you have to do if that happened? You'd have to divide. Look at this. Of course, I don't have one up here to look at. You'd have to divide this mess into, if you did change that to a cube, maybe something like this. And guys, I'm just creating something real quickly. And do long division. And come up with like an equation. It's going to graph into a line, and that line's going to be an oblique asymptote.
So that's if the top one is greater than the smaller one?
That's when the top is exactly 1 larger. A 3 and a 2, a 4 and a 3. As long as the one on top is 1 larger, we call that an oblique asymptote. And it requires long division. And it's in your notes. I just thought I'd warn you just in case. Yeah, I saw him. Yeah.
I was gonna say, and if the volume is larger, the exponent?
Oh, beautiful, beautiful. Here, look at this, look at this. Look at this. Now he's thinking about this. Professor, keep that. But make this one down here 1 larger. Anyone tell me what might happen always if you flip it? The one on top is not 1 larger, the one on the bottom is 1 larger.
0?
0. The x-axis is going to be your horizontal asymptote. Okay? Guys, I think this is going to help. I can imagine you coming in Monday and we didn't have this. And it's being recorded to be sent out also. Right, Mr. Park? Yeah, you hear me. So I'm glad you're here.
He's asking to record it.
This is, yeah. Okay.
It is recorded.
Okay, okay. Whew. So far, so good? Now, you gotta keep in mind, I stand here and I look at the time here, almost an hour. This is, probably chapter 1 and chapter 2, maybe? I mean, chapter 4. Have we done a polynomial function yet? No. Have I done a trig graph yet? No. I've got some things on the handout we gotta look at. Okay, guys, we good with this? Okay. Now, part, in the order I want to do here, sure enough, part 4, I helped myself out. Part 4, yes, you will have a trig graph, and I chose for you to go back to exam 5 and look at the last one we did on exam 5. So that will save me from I don't have to graph it. It was on exam 5. I sent the solutions out to exam 5, so it's on exam 5. Okay? So just look at exam 5 there. I hope you're looking at all your exams. Now, if I flip this over, see what we got here. Oh my goodness, okay, good. Now it says find the domain, find the domain, find the domain. Now, guys, when I look at this, no graphing at least, we've got the hard part out of the way. Graphing's done. Aiden, as I stand here, read that to me as I mark this down. What's the first function I'm asking for the domain?
F of x
Okay, equals
natural log of 4 minus x squared.
natural log 4 subtract x squared. Guys, what do we know about logarithm?
Greater than 0.
And this part right here is called the argument. He's exactly right. Must be greater than 0. That works for all logs. I'm gonna go ahead and factor. I think it'd be wise to factor in the order I see it. And then to finish this up, the old reliable sign analysis. So my critical numbers will be 2 and -2. They're open. You guys will save me a little time here, you know how sign analysis works. I'm standing here and seeing maybe I have an idea of in between works. If I put a 0 in, it does work. Start testing. Looks like in between will work. I don't think the ones on the outsides will work. So my answer here for a domain then would be -2 up to a +2. You're done. Aiden, what was the second one?
G of x is equal to square root x minus 3 over x squared minus 5x plus 4.
I mean, x squared minus 5x
Yeah.
plus 4.
Mm-hmm.
Okay. And I want the domain on this. Guys, this is one where you have to tear it apart here. My square root, since I see a square root, I know this must be true. X subtract 3 must be greater than or equal to 0. The bottom part will factor x subtract 4, x subtract 1. And can you tell me real quickly on the side here, what can you tell me about the denominator?
Greater than 0.
That's something else, no.
X can't be.
Yeah, x cannot be 4 or 1. And that in essence is the domain. But now I've got to think about putting all this together. I would, now this is not sign analysis, if you want to write yourself a note here, this is just a visual of what's going on here. The first part, of course, is x is greater or equal to 3. I can show that. Visualize what it looks like. I'm look like that. That shows x is greater or equal to 3, but at the same time, we cannot use a 1 or a 4. Sarah, it seems like we worked this one in the session the other day. We have 1 here, can't use it, and we have 4 here, can't use it. You remember this one?
I remember this one.
So that's just visually what's going on here. Now, can you name the domain for me?
Yeah. It was, bracket 3, well, bracket 3 to, 4 union, or
Beautiful.
no, parentheses then union, and then parentheses 4 to, infinity.
Infinity. You don't have to worry about the 1. It's on the other side, it's open to begin with. So that's my domain. Done. Aiden, what's number 3?
H of x
Hang on now. H of x is equal to
inverse sine
inverse sine of what?
x.
Oh, giveaway. What's the domain?
Square root 2 pi.
I know what you're thinking. I know what you're thinking. That's why I brought this in. I want the x. Was there some type of a restriction on the x for
-2
m?
pi over 2.
I know you're thinking the same way he's thinking.
-pi over 2.
Nope. Got you on this one.
You set us up.
I said yeah.
Oh. Yeah.
Now, let's think about it.
-1 to 1.
Oh, I got you. Somebody said it. You can only replace x by -1, in fact, that's my domain. -1 up to 1, you can include those for an inverse sine. Now, what you guys are thinking about is what's coming out. And for an inverse sine, that's called between this, Aiden, Samantha, you guys are thinking about between -pi/2 and +pi/2. That's what's coming out. To put in right here, you're caught here. That's my domain. Okay? Yes, no? We're gonna do this on the side here. David, on the side here, real quickly. If I have inverse sine, and I know inside here, I have a restriction, I've got to place inside a number caught between -1 and +1. I'm gonna try one that you're accustomed to. -1/2. Now, where have you seen sine equal to a -1/2 on the unit circle to begin with?
Pi over 3, or, no,
Negative pi over
Negative
six.
pi.
Okay, I'm hearing something.
4 pi over 3.
Negative pi
No,
over
not pi over 3, you're getting pi over 3 and pi over 6 mixed up.
Oh,
Is this a pi over 6? Finding what there has for a sine, why?
7 pi over 6.
Pi over six.
Okay, let's get the ones, what are on the unit circle first, or it's what, 7 pi over 6. I'm doing the calculation in my head here.
11 pi over 6.
11 pi over 6. And guys, I think, okay, 210, absolutely, 330, absolutely. Those two are negative, and they're -1/2 for sine. But now, this is what you guys are talking about. The answer coming out, though, must be caught between, by restriction, between what? -pi over 2 up to a +pi over 2. That's what you guys are looking at.
What's the difference?
so it's
Yeah, this one tells you where the answer is gonna be located. This one tells you what you are allowed to put in for the x to begin with. Guys, -pi over 2, +pi over 2, this is not caught there, this is not caught there.
11 pi over 6.
Exactly, we do 11 pi over 6 first, which I think is in what, quadrant 4? Like 330 degrees. I would just use 30 here for a little reference. And I have to rename it to make it fit that restriction, because these have to be one-to-one functions. It's gonna be where, guys, to make it fit, you're gonna now turn which direction, this way? And rename it as what? -pi over 6. Let me put bottom side here. So if I rename it, it will now fit between these two. It's called -pi over 6, it's -30. Yes, no? Okay, I think that's what you guys were thinking about. Now, Aiden, before I leave this, if you saw this, and I think Mr. Parker had on his extra credit, something like this. If you saw this on the exam,
No,
you quickly say there is no answer, period. Inverse sine 2, no. Okay? You place inside there something caught between -1 and 1, it's not gonna work.
Right.
Okay? Yeah,
How do we get -1 and a half?
negative, where's,
She's using an example.
That was just,
where are you?
She was talking about the other problem.
Oh, right here.
Yeah.
How about, okay, right here, good question here. Look back in your notes and see, because I think I gave you the domain and the range. The domain on the inverse sine is caught between -1 and a +1, inclusive. Okay, the range, the answer coming out that usually we were looking for in class, it's caught between these two.
Yeah.
Okay, but inside here, you got to place something between -1 or a +1, just like I just now placed 2, that's impossible. So there'll be no solution. It's got to be caught between these two. Okay?
Yeah.
Was there another domain?
No.
Beautiful, beautiful. Okay, guys, let's see what's next before we get this finished up here.
complex zeros.
Oh, find the complex zeros. It's been a long time since you've seen one of these. Now, there's some issues on this one. Just type when you see it. And that issue is, you may be lucky and get a good start on it. Then on the other hand, it may not. It may slow you down. Okay. Sarah, read that to me as I write this down. The P of X.
P of x equals x to the 4th
Okay,
minus 5x to the 3rd
okay,
minus 5x squared
okay.
plus 23x
Wow.
plus 10.
Plus 10. Guys, we gotta get 4, the degree is 4, gotta get 4 zeros. And some of those may be imaginary. Now, does anyone remember anything at all that we did here? Sophia?
Sign change.
Sign change. We're going to go through the sign change. I see 1 here, 9 here, 1 here, and none down there. What's that, those two sign changes tell me?
Two positive ones.
I could expect, of the four I'm expecting, I could expect two of those to be what? Positive. Or, yeah, the rule says you could reduce that down by two, maybe none are positive. It's either two or none are positive. How do you find the number of negative possibilities? You find p of a negative x. And guys, if I replace x by negative x, I'll do it fairly quickly. You're going to end up with this. I go watch my signs. It looks like this. Replacing x with a negative x and simplifying. I think we're okay. Sign changes. Nothing here. Here's one. Nothing there. Here's another. I'm going to end up with the same possibility. So the number of negative real zeros coming out of those four could be two or none. So that would help. Does anyone remember something else besides Descartes? That's Descartes' rule of signs. Something else we had to use. Sarah.
The possible zeros,
P over Q.
yeah, P over Q.
Everybody, P over Q. We call this the rational zeros theorem. The P was a factor of my constant term, the 10. Guys, I'm gonna write those factors of 10 like this. My Q, a factor of my, we lucked out here, the factor of my leading coefficient. The leading coefficient is a 1. So I don't have anything to work with but plus or minus 1. Now, this is where synthetics will come in. And this is where you, let me set this up for you. A number in my original function, coefficients for these.
Wait, so for the Q, you just put the leading coefficient of,
Absolute factors of my leading coefficient. And we left out here because my leading coefficient is 1. Okay? Guys, does anyone see, as you start examining these possibilities, one that might work, P over Q, and I'll test it? Got one
No,
there?
I had a question. So how do you get the P's, all the P's?
Which one again?
Like, how do you get that P?
The P right here?
Yeah.
These are factors of your constant term.
Oh, off the 10? Oh.
Go down to the end and list all the factors of the constant term. The Q is a factor of your leading coefficient, understood to be a 1.
Okay.
Okay? Now, does anyone have maybe a possibility that may work? And I'll test it. And that's the trouble on one like this on the test. You may test and test and test and oops, it's not working, it's not working, it's not working. And all of a sudden you're running out of time, you think, oh my goodness, either you've made a mistake or you just haven't found the one that works yet. Any possibilities here, guys? Something to test? Let's try 2. Now, if I try 2, I'm going to end up with this. Not looking good. In fact, I think I did that real quickly. 2, -3, -6, -11, -20, of course. It does not work. Doesn't work. It gives me some information, but it doesn't work. It does give me some information there. Guys, does anyone have maybe another possibility? And the Descartes rule says maybe there are 2 positives.
can you do
We haven't found any yet,
just try
or 2 negatives. Yeah, Samantha.
try one?
Try 1?
Yeah.
Let's try it. 0, 1, 1, -4, -4, -9, -9. Oh my goodness, right here, guys, what is it, 14? Not looking good. Let me step back and make sure all my numbers are correct here. Testing 1. Looks pretty good, but that's not. Have not found, I have 4 of these, have not found any yet. Five. 5. Let's try 5. Sometimes these things are strange. It will work. 5 here, guys. 0, 1, 5, 0. Don't let me make a mistake. 0, -5, -25, -2, look at this. Henry, thank you. You guys check my math there. Did I do the math correctly? So finally, we found one of the 4 zeros is a 5. Now you get to stack this up after you find one to work, and you get to test with the remaining numbers there to make it work a little bit easier. Now, does anyone have another number I can test, either positive or negative? I'm getting desperate. Marco.
At this point, you say you can lower?
Okay. Okay, tell me what you mean by lower.
Once we found one, it's become cubed, so we can write that as.
Wait, no, if you do, gotcha, sometimes you look at it. Since, I'm trying to find where I am here. Henry gave me 5 at work. I know the remaining numbers, and by the way, I was expecting what? 4 altogether, we dropped out to a 3. So the remaining numbers name this, x cubed minus 5x minus 2, was it? Is equal to 0. Oh boy, I hope I had the thing written down correctly. Do I, guys? X cubed minus 5x, is it? X cubed, no x squared, x. I can't do anything with that myself. Sometimes in class, you remember, sometimes you could group or do whatever and save yourself from testing.
Yeah.
Yeah, Marco, good suggestion, but this one's not gonna work out nicely for us. So I need another number.
But then
Robert.
The numbers that apply.
-2. Here we go, let's try. Okay, 0 here, 1, -2, -2, 4, -1. We did, it works. It works.
You plug it in with the new.
You have to leave now?
No, no.
You plug it in with the new,
With the remaining numbers that are up here?
yeah.
Yeah. You can stack those up. Only when you find one to work, which we did, we found 5 to work. Now, guys, at this point, Marco, I will use your suggestion. Can you tell the class what 1, -2, -1 tells me at this point if everything's correct?
Would it be x squared
Thank you.
minus 2x?
Look at that. Now that, I can solve myself. No more testing. Guys, when we use quadratic formula, this thing's not going to factor. If I use quadratic formula, I'm doing it quickly now. I'm going to end up with a 2 out front, plus minus square root. We end up with 4, subtract 4 times a times c, all over 2. Now I did that real quickly, we know how to use quadratic formula. So this is 2 plus minus, I think it's a square root 8. I think you end up with 4 plus 4 over 2, 8. Simplified is 2 radical 2, all over 2. And then with all those 2's staring at me, you can simplify or divide by 2 and make this look much better as 1 plus minus radical 2. And that should be the other 2 answers. Wow. It's been a long time since I've seen one of these. Sophia, do we now have 4 zeros? Finally.
Yes, sir.
Okay, now can you tell me, and I'm gonna ask, after you find the zeros, can you now tell me what the original polynomial function would look like in factored form? And guys, let me list all the solutions.
Is it x minus 5?
Okay, hang on a second. 5, -2, I'll get back to you. And we've got, if there's no mistake, 1 plus radical 2, 1 minus radical 2. Aiden, give me a start.
X minus 5
It is x minus 5,
and x plus 2.
x plus 2. Now, the last two are a little strange. How would I get 1 plus radical 2? What does the factor look like? There.
Wouldn't you just leave it as x squared minus?
Beautiful, she says, Professor, if you say, just give me the factors, she said, can I not just attach to this, and be done? But if I say, no, I want only linear factors,
Can you use
Now, let me redo it. I'll keep this is linear, no quadratic. This factor is linear, no quadratic. And I did not, for some reason, want a quadratic.
Can you
Now, tell me
use
another way to express it.
I?
Method.
Can you use I?
There's no I in this one. And sometimes you get an I, you may get an I on the test, but there's no I in this one. You clever guys, tell me how on earth would you get, let's say 1 plus radical 2, and place a factor here that would give you 1 plus radical 2. Sarah, go for it.
It would be x minus x minus 1 plus radical 2.
Hang on. And what was the other one
And
look
the
like?
other would be x plus 1 plus radical 2. Yeah,
Okay,
because
I'll
then
see.
you make it equal to 0, and both of those would have to go on the other side.
Okay, let's test it.
Oh,
Problem test.
that's wrong.
Now, if we do, I test you guys, and this one you gave me. For a little test, I know if I set that equal to 0 and solve it, the one Aiden gave me, yes, I get 5. It works. If I take this one that was given to me, x plus 2, I solve it, do I get -2? This one. Now, Sarah says, being clever, she says, now professor, solve this one. Which looks a little strange, but set equal to 0. Move those terms over, and please tell me, would you end up with that? And was that one of the other possibilities? So I agree 100% with that. Now she says, maybe professor try on the end here, bring it here, guys.
Can you minus 1 plus radical?
Yeah, I think it was 2, gotcha. But she says, try this, solve it, move those 2 terms over, and you get that, where you're close.
You can do plus 1 minus radical.
Okay, you want maybe a -1 here?
No. Oh yeah, minus 1 plus
Minus
radical.
1 there rather than a +1. Let's do it, put that minus in there. And a minus here, now would give me, and put right there, move that 1 over, will that now give me the other one? Is that true? Lord, I hope it is.
Yeah.
Okay.
Wait, no.
No, we just renamed it.
Yeah.
We renamed it. So how am I gonna get the other one?
Maybe
Would you
minus,
just
oh,
subtract
minus,
the-
the.
Minus radical
Yeah,
2?
minus radical 2.
Here? Okay, right. Let's go back up. Now move both those over, are you going to end up with 1 plus this time? Radical 2, and is that the one I was missing? Yes. Isn't that a joy to see one of these?
No.
Yeah, you haven't seen it for a while. You told me way back you love polynomial functions.
It was.
That's why I brought this one in. You love polynomial functions. Hey guys, by the way, I'm not gonna sketch this. If you were asked to sketch, this is the type you gotta see where it crosses, touches, all that business. I'll do some of those. Any concerns here on this one? Okay. Sarah? Thank you for your help there.
I have a question.
Go ahead.
So like in the beginning, once we found the first answer, say it just figure this.
Oh, if it does work, go ahead and take it out and factor and do whatever you gotta do with it.
Would it be like the first number will be the next exponent and then
Okay, I gotta find where you are. Are you talking about right, where was it, here?
below it?
Okay, below it, oh, down here.
So the one, yeah.
Okay, that would be x cubed,
Yeah.
0x squared, minus 5x, minus 2. In fact, I think I wrote that somewhere over here somewhere.
Up there, yeah.
But I can't do anything with it. Now, you're hoping though on Monday, after you do that, you can do something with it, and therefore you need not worry about testing additional numbers. By synthetic. Yes? No? Now, we'll get through all this. Where are we ever? Guys, where am I? Oh, solve. Here we go. you guys need a break,
Yeah.
or just go continue and get this done? Are we okay to just get this done? Because it's gonna take me just a little bit of time to get this done. We're almost finished, this is the last page. Okay, let's get done. A,
Yeah.
what side of it? Tell me what the first equation is to solve.
Alright, it's,
Mr. Parker, how's this looking for the recording?
It looks good.
Okay. We gotta send this out. Okay, Aiden, tell me what that was.
e to the x, or exponential,
E to the x,
minus 12 e to the negative x, minus 1 equals 0.
beautiful.
Is this like u or no?
Not yet, oh, you know what, we could, if you want to let u be something.
Can you do like natural law?
All right, and then a natural law come in maybe later on, not right now, but at the initial, he says maybe it's one of those where you let u be something. What might you let u be
E to the
at
negative,
this point?
e to the negative x.
Okay, if you want to try that. Now, what are you gonna put here?
Alright,
I know what you're gonna put here, this is 12u. If I let u be a negative x, e to the negative x.
so then you have to rewrite it,
Like what?
e to the x to the negative,
Now, you're getting close.
or e to the negative 1 to x.
Yeah, I can tell you, you've already put some study time in. You're getting very close.
12, 1 over e to that.
Right here, that's it. This means this. If you wanna rewrite, 12e to the negative x is the same as 12, and then move that like a reciprocal e to the x down there. If I do, I now have it to look like this. Now, before I ask you what to let u be, what else can I do to simplify this a little further? Multiply through by e to the x? I think someone's suggesting that. And guys, be careful, when you multiply everything by e to the x, just to sort of clean it up, this times this is e raised to the 2x, you add the exponents. The nice thing is, e to the x times the next term, e to the x's cancel, got minus 12. And a minus 1, of course, times e to the x gives you that. Now you got that. I multiplied everything by e raised to the x, e raised to the x, e raised to the x. I'm gonna place this in order. Now, Aiden, we need your help. That looks nice. Now, what would you let u be?
X, e to,
E to the x. Which will work out much better now since I've cleaned it up. So guys, this right here becomes u squared, the first term, minus u, minus 12 is equal to 0. And I should point out that this is being recorded. E to the x squared looks like that, which is the same as e to the 2x. This will factor into this. And if you split this up, you end up with u is equal to 4, u is equal to a negative 3. Now, what should I do now to finish this thing up?
Plug e to the x.
Absolutely, replace u by e to the x. And guys, if I do that here, look here at this. You got e to the x, e to the x. Now, can someone tell me what's x?
L and
4,
Right.
4x.
Hang on, x is what now?
4.
ln 4, don't skip it up 4, ln 4,
Yeah, but the other one will more.
that's all. And what's this one?
Nothing.
Nothing. E to the x will never be equal to a negative number. Final answer, Marco, ln of 4. On the equation there. Go for it.
Could you explain the first step again? Like, why did you take out e to the x?
I didn't take out e to the x, all I did was think about this as a reciprocal, that part right there. That means this, if you like to rewrite it.
Yeah.
I did that just so I could let u be e to the x that Aiden mentioned earlier.
But aren't you like multiplying e to the x?
You can do this.
Like to the next
Look at this. I've seen some students do this. I know exactly what you're thinking. Here's the original problem. y is equal to 0. I've seen some students do this. They'll say, Professor, let's go ahead and multiply everything by e to the x right at the initial. That might clean it up, because these two multiply together. When you add the exponents, will be this. When you add the exponents here, you get e to the 0, which is 1, so you get 12. And put on the end minus e to the x, and you'll eventually end up with the same thing I did. You could just clear it out by multiplying everything by e to the x. And then let u be something.
Yeah, that's what I thought you did.
Yeah, exactly, it comes up to be the same thing. Guys, anything else here? Okay, A, what's number 2?
Log base 2,
Log base 2,
x plus 2,
x plus 2,
plus log base 2,
log base 2,
2x minus 3 is equal to 2.
equals 2.
Right.
Okay. A log equation. Guys, I see a plus on there, which might indicate to me
Multiplication.
multiplication product. So let's rewrite this as log base 2, and let's write this as x plus 2 times 2x minus 3, that's a product, equals 2.
Squared.
Now, be careful. What does that mean?
It's log, it's 2.
No, that's not. What does it mean at this point? This is correct here.
2 to the second.
Yeah, 2 raised to the second in this case is equal to this. Just translate the log, drop the word log, and tell me what it means. Which is what, 4? It's equal to, let's expand this guy's 2x squared, 4x minus 3x plus x minus 6. And if I move it over and put this in correct form, it looks like that, I hope. I hope it factors. 2x, x,
Plus 5 minus 2.
oh, plus 5, thank you, plus 5 here, minus 2 there, correct. Split this up, we'll get x to be a negative 5 halves, and x is equal to 2. Guys, which one might be rejected?
Negative 5.
And how does one tell? Just because it's negative?
Yeah.
No. That back here, if you go back and replace back here, will it make it negative? And it just so happens it will in this case. I think it's what, negative 2.5? So a negative 2.5 plus 2 gives me a negative here. You can never take a log of a negative. So that's why it's out. Therefore, I would accept 2, and what I would do, when I had the time there, I would check and make sure it does check. That looks like 2 is the answer on that log equation. David?
So, if x equaled a negative 1, for example, it would still be a valid answer.
Look at that, look at that. It won't mess, it'll mess this one up though. It's gotta satisfy both.
Okay, well, let's say it was a
It
negative.
will satisfy both,
And it
then you
satisfies.
accept it.
Okay.
Beautiful. So you may get a negative number, and if that negative number, take it back to the original, satisfies everything, accept it. Here it would not. Number 3, Abe, what's number 3?
Cosine 2 theta
We're about to get this done, guys. 2 theta.
minus cosine theta is equal to 0.
Okay. Now you better know your formulas. And you got a ton of them. Does anyone recall any type of a formula for cosine double theta? Double angle formulas.
2 cosine theta.
Oh, get close. In fact, I think this one had 3 versions. Does anyone recall? We did this just recently.
1 minus cosine squared.
No?
2, 1 minus 2 sine.
Oh, you guys are all around it.
1 minus.
I think the original was like cosine squared minus sine squared?
Yeah.
Yeah. And I notice there's no sine in this one, so I need another version.
The 1 minus 2 sine theta.
We'll get close.
Sine
What
squared theta.
minus 2 cosine?
I think it says 1 minus, what was it? 1 minus 2 cosine squared
This is the formula for what? What is it called?
for cosine double theta.
So double formula.
Double angle formula. And she suggested that, of course I still got this. You gotta know your formulas. Are we using the right one? Or not?
Yes.
Okay. Now, if I put this in some type of order here, guys, I'm looking at this.
Let u be plus.
There you go. Put that one on the end. And Sarah says right quickly, come on, let u be cosine theta. And she's gonna make this negative 2u squared minus u plus 1 is equal to 0.
Plot into the 1 minus, like that?
I just turn things around up there. Put it in order. Up here, I put it in this order here as a quadratic. You guys agree? I hope. We're gonna check this and make sure. I'm gonna change these signs. A your estimate this is 2u squared plus u. I think it looks better like this. And Sarah, since you gave this to me, I hope it factors. 2u, u plus 1 minus 1. Split this up. We end up with that. And hopefully that. And she says let u be cosine theta. Here goes, guys. Cosine theta is equal to 1/2. Cosine theta is equal to a negative 1. Now, can anyone tell me on the unit circle, where have you seen cosine equal to a 1/2 to begin with?
5/3.
5/3 is one of them. That's an answer. And there's another spot on the unit circle where the x-coordinate cosine is 1/2.
7. No, it's
5,
5/3.
5/3? You guys agree?
yeah.
And then where have you seen cosine, the x-coordinate equal to a negative 1? Pi. Well, if all this, and I don't have time to check these guys, it's pi/3, 5/3, and pi. There's your trig equation solved, and let's hope we don't have a mistake on this. Let's hope we don't. Okay? Aiden?
Yeah.
What's the next one? Yeah, we got time. To solve. Was there another one to solve?
Yeah.
Like what?
2 sine,
Hang on a second. Another trig.
yeah,
Okay, read that to me.
2 sine,
2 sine squared?
no, just 2 sine,
Oh, 2 sine.
3 theta,
Oh, 3 theta, okay.
minus 1. And, is equal to 0, and between 0 and 2 pi.
Okay, the answer, that'll be called between these two. Okay, guys. Give me some suggestions.
Move the 1 to the
Move the one over. As is. Divide by 2. As is. Good, a little partial credit, at least should be that. Now, here's the problem. How you gonna go, where are you gonna go from there? Yes,
Isn't it like sine squared plus cosine
no,
squared?
You
I'll
just
give you a
box
hint.
out sine and,
I'll give you a hint.
so you find them, then divide by 3.
Yeah, where is sine 1/2 first?
5,
5 or 6, and what is it, 5 or 6? I'm bad with the right numbers. So that means this 3 theta is representing pi over 6. I gotta write like this, and the period number for sine is 2 pi k. Where k is an element of integers. Or, another possibility is 3 theta could be representing 5 pi over 6 plus 2 pi k, where k is an element of the integers. Wow.
Just.
And then divide by 3. And when you divide by 3, it's gonna look awkward. We'll take 1/3, we'll end up with pi over what, 18? Plus 2 pi over 3k, where you're supposed to replace k by the integer. And here, 5 pi over 18, some strange numbers, plus 2 pi over 3k. Now, I'm not gonna finish this one up. I'm going to show you some possibilities. Those are called general solutions. Guys, he told me they were asking for answers only caught between 0 and 2 pi. I see an 18 in there. Whew. Maybe I should change this from 0 up to, let's call this 36 pi over 18, which is the same as 2 pi. Because I see that pi over 18 coming in. Now, does anyone remember what we had to do at this point?
Let k equal, for example, 0.
Thank you. Let k be 0 and see if it fits up here. If so, you use it. Then let k be 1. Crunch it out. If it fits, you use it. Let k be 2. If it fits, you use it until you run out where you can't use it. And you do the same thing here. Let k be 0. Let k be 1. Let k be 2. Make sure that the answers fall between these two. It looks like there might be 6 answers here. I didn't actually find the answers for you. You remember the little process there?
Mhm.
Now, was that the last equation to solve?
Yeah.
Beautiful. Now we're down to the end, which is going to move a little bit faster for us, I think. Tell me, Aiden, guys, I appreciate you doing this. Really appreciate you. And Mr. Park, I appreciate you, for those who are not here, that you have the recording for us. What's the next item?
Using identities presented in class, prove the following.
Okay.
Tan theta sine theta plus cosine theta is equal to secant theta.
Now, we gotta finish this up. Woo! Now, can anyone give me an idea of what type of an identity could you start replacing and try to work it out? And he's telling me, Professor, when you finish it up, these two sides should be equivalent. Any ideas?
Should we change secant?
I could. I know secant is,
1 over cosine.
it is 1 over cosine. I agree with him 100%. You wanna do that right now? No problem. Man, hey, you've been prepared for this. Now, how about on the left-hand side?
Just,
Can you change tan?
yeah.
2 sine over cosine.
There you go, that may help. So this is sine over cosine.
And then sine over 1.
Oh, I got you. So math is sine over cosine. If you guys are not the top students in that math 7 class, you guys are doing math 7. And better be top students. Sine theta here. And she wants you to put double 1, which you can. Still got this. So guys, actually you got sine squared. Now look at it closely. Over cosine plus cosine. Now what can I do with that?
Cancel cosines?
Well, what would you do in arithmetic for solid? Put them together with a common denominator. If you do, something nice happens. You want to use a common denominator of cosine, so you gotta multiply this one over here by cosine, which is going to have you to end up with cosine squared. And all this is over a common denominator of
So
cosine.
it's 1 over cosine.
Look at that. That's 1 over cosine. 80, the two sides now match up. And that's what they wanted. Done. Finished. Okay, guys. Of course, you're going to look through these and reviewing for yourself. I'm glad you see this with me right now. Hayden, what's next? Is it a summation?
Yeah,
A summation?
yeah.
Okay, summation. Okay. tell me
Write
what-
the first 5 terms of the sequence.
Oh, well, that's not a summation.
Oh, so it's A subscript
Oh, A subscript,
1
1,
is equal to 3.
3, okay, tell me more.
I think it's A subscript 2 is equal to 2A.
A subscript. Yeah, say A subscript N
Oh, yeah, A subscript N,
equals
2A,
2A
subscript,
N minus 1,
N plus 1.
right? Looks like N minus 1,
Oh, N minus 1 and then plus 1.
yeah. And then
Plus 1.
plus one out here,
Yeah,
like that.
yeah,
And then I'm asking you to write the first, how many terms?
5 terms.
5 terms. Guys, here goes. Watch carefully, we're about to finish this up. I know it's been a little tough on us. Now, the first term is 3, no problem. That's out of the way. Second term, look at this, guys. A subscript 2, that's where the second term looks. By his formula, it says 2 times a subscript n minus 1, in my case 2 minus 1, plus 1. And therefore this now becomes 2 times a subscript 1 plus 1. And this is 2 times a subscript 1, thank goodness it's given to me as a 3, plus 1, arithmetic 7. Now, I doubt if I find all 5, I'm fine enough just so you guys understand what's going on. Aiden, let's find the third term, which is represented as a subscript 3, I'm looking for it. A subscript 3, by your formula, it's right here, is 2, a subscript 3 subtract 1, n minus 1, plus 1. So this becomes 2a subscript 2 plus 1. Hey guys, how would you find it now? How would you finish it up? You got 2a subscript 2 plus 1, how would you finish? What was a subscript 2 earlier? 7. Now you get to replace the 7 there, you found that earlier, plus 1, arithmetic, 15.
How did I know that's 7?
What's that now?
How did I know that's 7?
7 came from this. This is A1, this is A2 here. That's what I needed. I needed A2 right here.
Oh, okay.
And A2 was 7. And these terms depend upon the previous term. So I can find the next one, find the next one. Okay, so you guys could practice with that. You can find the other 2 terms. Are we okay with this, guys?
Yeah.
Trying to find terms. Beautiful. And Aiden, what's left?
Given sine A.
Okay, got you. Hang on. Is this the last problem?
No,
Is there one more?
there's like 5 more.
Well, we've got 5 more.
Yeah. You have applications of.
Oh, no, I probably just mentioned application, I didn't give you examples.
Oh, yeah.
Okay, so this might be, I think
Yeah,
I have a
there's one more.
summation there coming up.
Yeah, then there's one more.
Okay, now tell me what the other one is.
Sine A is
Sine
equal,
A,
is equal to 1/3.
got you.
And then secant B
Secant B,
is equal to 5/4.
5/4.
Yeah.
This is nice.
And where A and B are in quadrant 1,
If they're in quadrant 1, everything's positive.